Hello everyone, myself Deepak Kumar. I am working as an assistant professor in the Department of Electronics and Communication Engineering in the RKJIT College. Today I am here to give the lecture on the topic which is related to the subject Fundamental of Electronics and Communication, Fundamental of Electronics Engineering, taught in first year, BTech first year. The code is BEC101. So these are the contents of my lectures. The first we will discuss the introduction about the operational amplifier, then the characteristics of an ideal operational amplifier, then symbols and the pin diagram of operational amplifier, and then their configurations, open loop configurations, closed loop configurations, and some specified configurations like inverting closed loop operational amplifier, non-inverting closed loop operational amplifier, and followed by voltage follower, summing amplifier, differential amplifier, integrator circuits, and differentiator circuits. Like next please. So basically this is the introduction part of the operational amplifier of my lecture. Basically the operational amplifier is a high gain electronics device which used to amplify the difference of applied input signals, and basically it is available in it is having two terminals, two input terminals and one output terminals. So the one of the input terminal is known as the inverting input terminal and the second is known as the non-inverting input terminal. So basically the operational amplifier is widely used in the processing of signals like amplification, filtration, comparison of the signals, integration, and some kind of signal processing. So generally we use the IC 741 is generally operational amplifier IC which is used in electronic industry. Next. So now come to the characteristics part of the operational amplifiers. These are the ideal op-amp characteristics. The first one is the infinite open loop gain. So this is the basic characteristics of this is the essential characteristics of the ideal operational amplifier. The gain of the operational amplifier should be infinite. Then second is the input impedance. It should be infinite for ideal condition, and it should be maximum as much as possible for the practical conditions. The next is the zero output impedance. For ideal condition it should be 0, but for the practical purpose it should be as much as less it is possible. Then next is the bandwidth requirement. So bandwidth requirement should be infinite for ideal condition. It means it amplifies all the frequency signals without any distortions or attenuations. Then next ideal characteristics is the slew rate. Slew rate must be infinite for ideal condition, and last one is the infinite common mode rejection ratio. So this is the another property or the characteristics which rejects all the common mode signals which are given to the input of the operational amplifier. Next. So now come to the symbols and the pin diagram of operational amplifier 741 structure. So this is the pin diagram of 741 structures which is available in the 8-pin dual inline package, and the pin numbers are 1, 2, 3, 4, 5, 6, 7 and 8. The pin number 1 is known as the offset null pin. Pin number 2 and pin number 3, these are used as an input terminal pins, in which the pin number 2 is known as the inverting input pin and the pin number 3 is known as the non-inverting input pin. Pin number 4 and pin number 7, these are the dual supply pins. So basically the 741 IC is dual supply operated IC, in which we apply the negative supply at the pin number 4, and the pin number 7 is at pin number 7 we apply the positive power supply. So pin number 5 and pin number 1 same, these are same pin, these are the offset null pin. These are used when we have some output offset voltage, and then to minimize the output offset voltage, we apply a thermistor, a potentiometer, a variable potentiometer across the pin number 1 and pin number 5 to nullify the output offset voltage. So pin number 6 is used as an output pin. So if the complicated pin diagram is represented by a symbol, this is the symbol of operational amplifier, shows by a triangle followed by 2 input terminals and 1 output terminals, and these are the 2 supply pins. Positive supply is pin number 7 and negative supply is pin number 4. Output is taken by pin number 6, and negative input terminal is pin number 2 and positive input terminal is non-inverting input terminal it means it is pin number 3. Next. So now come to the configurations of the operational amplifier. So basically the operational amplifier is configured into 2 types of configurations. The first one is known as the open loop configuration, and the second one is known as the closed loop configuration. Now come to the open loop operational amplifier configuration. In open loop operational amplifier, there is no feedback connection between input and output. So we can say that the operational amplifier without feedback is known as open loop configuration. So in open loop configurations, the output of the operational amplifier is represented by output voltage V naught is equals to gain multiplied by the difference of applied input terminal voltages. So V plus is the voltage across the positive input terminal, or we can say at the non-inverting input terminal voltage, and V negative represent the potential at inverting input terminal. So the output voltage V naught is proportional to the difference of applied input voltage across the input terminals. So then AOL, where AOL is the open loop voltage gain. So basically the voltage gain is nothing, it is the ratio of output voltage to the input voltage. So this is about the open loop operational amplifier. Now come to the closed loop operational amplifier. So there are some limitations of the open loop operational amplifier. We can only amplify the weak signals, and it can use in non-linear applications also. So to make the adjustable gain or the more stable circuits performance, we require some feedback network connection across the terminals. So if we connect a feedback network across the input and the output terminal of the operational amplifier, then the configuration is known as closed loop operational amplifier. It is a highly stable circuit which provides a highly stable output, and it is basically used in linear applications. So this is the circuit diagram in which we connect a feedback network. This is with the help of a resistance RF, and the two input terminals voltages are V1 and V2. These are the input terminals. The output is connected to the input side, that is known as the feedback process. So we can conclude that the operational amplifier with the feedback network is known as the closed loop operational amplifier. Next is, so these are the further configurations of the closed loop operational amplifiers. So in closed loop operational amplifiers, we use the feedback network. In this configuration, we use the negative feedback network. We can also use the positive feedback networks, but in this case we use the negative feedback networks because the negative feedback networks provides the highly stable output, and the circuits are very stable as comparison to the positive feedback. So in negative feedback network, an output is connected to the negative terminal, and this configuration is known as the closed loop configuration. But now we are going to discuss the inverting amplifier. As the name suggests, that if we apply the input signal at inverting terminal of the operational amplifier and the non-inverting terminal of the operational amplifier is connected to the ground, then the configuration is known as inverting closed loop operational amplifier. In such kind of application circuit configurations, the output signal will be 180 degree out of phase with the applied input signals, and the output is given by the equations V naught is equals to minus RF upon R1 into V in. If we calculate the gain, that is AV represents the closed loop voltage gain, that is the ratio of the output voltage to the input voltage, that is equals to minus RF upon R in, where RF is the feedback resistance network and Rn is input side resistance, and with the voltage level V in. That's it. Next is, so now come to the non-inverting amplifier circuits. So this is the reverse process of the inverting amplifiers. If we connect the input signal at the positive terminal or non-inverting terminal of the operational amplifier, and the inverting terminal of the operational amplifier is connected to ground, and there is a feedback network between input and output with the combination of the two resistances RF and R1, then the configuration is known as non-inverting operational amplifiers, or we can say simply non-inverting closed loop operational amplifier, because there is a closed loop or there is a feedback network exists, that's why the name is the closed loop, and the signal is given to the positive terminal, that's why the name is non-inverting closed loop operational amplifier. So in such kind of circuit configurations, the output and input both will be in the same phase. There is no phase difference between across the input and the output. So output will be the amplified version without phase change of the applied input signal. That's it. Next is, so next is the voltage follower circuit. This is another type of the configuration, or we can say this is the operational amplifier configuration to perform some specific tasks like voltage follower. As the name suggests, a circuit which is designed to follow the some kind of voltage, that is known as the voltage follower circuit. And the another name of the voltage follower circuit is known as the unity gain amplifier. Why the unity gain amplifier? Here is the circuit diagram of voltage follower circuit. This is the special arrangement, and this circuit is designed with the help of the non-inverting closed loop operational amplifier with 100% feedback network. So complete output circuit is given to the inverting terminal and the signal is given to the non-inverting terminal. Then the resulting configuration is work as the voltage follower circuit. It means output voltage always follows the applied input signal. So we can say that the output V naught is always equals to V in. If we find out the voltage gain, that is the ratio of the output voltage upon input voltage, it means AV, that is equals to V naught upon V in, that is equals to 1. That's why the another name of the voltage follower circuit is known as unity gain amplifier. That's it. Next. Now come to the summing amplifier. Summing amplifier is a circuit or which is designed with the help of the closed loop operational amplifiers and used to perform mathematical addition operations. That's why the name is summing amplifier. It is also known as the adder circuit with the help of operational amplifier. So when the operational amplifier work as an adder circuit, if we connect n number of signals at the inverting terminal with a combination of n number of resistances and the feedback resistance RF, and the non-inverting terminal is connected to ground, then the resulting circuit is behaving like an summing amplifier or adder circuit. The output of the circuit is proportional to the algebraic sum of all the applied input signals like V1, V2, V3 up to Vn. If we apply 3 signals V1, V2 and V3, then the output is proportional to the sum of the V1, algebraic sum of the V1, V2 and V3. So this is about the summing amplifier using operational amplifier. Next is integrator circuit. As the name is operational amplifier, because it performs some mathematical operations also with the combination of amplification. So integration, this is the another mathematical operation, and the circuit which is used to perform the mathematical integration is known as the integrator circuit. To design the integrator circuits, we replace the resistance RF by a capacitor C, and the input signal is connected at the inverting terminal and non-inverting terminal is connected to the ground. Then the resulting circuit is behaving like an integrator whose output V naught is always proportional to the integration of applied input signals, and the mathematically the output is equals to -1 upon RC integration of Vi dt. If we apply the square wave at the input side of the signal circuit, then at the output side we get the triangular wave. Next is, so this is the another mathematical operation in differentiation. Then the circuit which is designed with the help of the operational amplifier and used to perform mathematical differentiation operation, or the circuit is known as the differentiator circuit. The output of the circuit V naught is proportional to the derivative of applied input signals. If the input signal is V in and the output is V naught, then V naught is proportional to the dV in upon dt, and the circuit is designed by replacing the capacitor R in by a replacing the resistance R in by a capacitor C, and this arrangement or this resulting circuit perform the mathematical differentiation operation. That's it. Next is the comparator circuit. This is the most important application of the operational amplifier. This is the comparator. So basically this circuit is designed with the help of the operational amplifier in open loop configuration. In open loop configuration, the operational amplifier can compare two voltage signals. So if we compare two voltage signals, the voltage signal, if we compare the V in, then V in is connected to the positive terminal, and at the another terminal we connect a reference voltage, or we can say a threshold voltage, through which we can compare the applied input signal. The output and is based on the comparison result will be the plus VCC or minus VCC. Plus VCC and minus VCC, these are the maximum dual supply voltage levels. Plus VCC, it means suppose we add plus 12 volt, and minus VE is minus 12 volt. So the output may be plus Vset or minus Vset. So never exceed the output, never exceed the its dual supply voltage level. And on the basis of the comparison, if V in is greater than reference voltage, if V in is greater than reference voltage, then output will be is proportional to the positive saturation, because the potential at the positive terminal is higher than the potential at the negative terminal, which makes the output is positive, and the positive level is positive saturation, that is equals to plus VCC. If V in is less than V reference, then the output is equals to negative saturation level. That is the voltage comparator. Next. Thank you. So this is about my lecture. Thank you so much.